Complex numbers having a real and imaginary part are binomials. Multiplying them follows the FOIL method. Welcome to Mathematics of Engineering. Say we are to take the product of negative 3 minus I times 6 minus 7I. For the purpose of clear discussion, solution is made through distributing the terms of the first binomial. Thus, we get negative 3 multiplied by 6 minus 7I minus I times the same quantity. Multiply the exterior factors to have negative 18 plus 21I minus 6I plus 7I squared. But what is I? I is equal to the root of negative 1. So taking its square removes the radical sign, leaving negative 1. So the solution now becomes negative 18 plus 21I minus 6I minus 7. Collect similar terms to have negative 25 plus 15I. For the second exercise, multiply 8I to 10 plus 2I. That would be 80I plus 16I squared, where I squared is negative 1, making the z as 80I minus 16. Arrange the terms to the standard form, thus z is negative 16 plus 80I. Another pair of binomials to multiply has negative 3 minus 9I times 1 plus 10I. Again, distribute the terms of the first complex number, making negative 3 times the quantity of 1 plus 10I minus 9I times the same quantity. Multiply the exterior factors to have negative 3 minus 30I minus 9I minus 90I squared. With I squared taken as negative 1, we make z as negative 3 minus 30I minus 9I plus 90. Collect terms now and get z as 87 minus 39I. Another set for practice is the quantity 2 plus 7I multiplied by the other quantity 8 plus 3I. Distribute terms of the first complex number and get 2 times the quantity of 8 plus 3I plus 7I times the same quantity. Multiply the exterior factors and come up with 16 plus 6I plus 56I plus 21I squared, where I squared is negative 1. So the expression becomes 16 plus 6I plus 56I minus 21. Collect similar terms again to have negative 5 plus 62I. How about we twist the problem a little bit? This time, we are to multiply 1 plus 2I with the square of 2 minus 3I. We first expand the square and get the square of the first term, 2, plus twice of the first and the second terms, plus the square of the second term. Simplify everything to have 4 minus 12I plus 9I squared, which can then be simplified as 4 minus 12I minus 9, reduced into negative 5 minus 12I. With the square already simplified, multiply the first complex number. So we distribute terms of the first complex number again. Multiply exterior factors and get negative 5 minus 12I minus 10I minus 24I squared. Convert I squared and get negative 5 minus 12I minus 10I plus 24, which can be reduced to z as 19 minus 22I. The next exercise has the cube of 1 minus 3I. We separate the complex number in a way having the square of 1 minus 3I. Expand the square and get 1 squared plus twice of 1 times negative 3i plus the square of negative 3i. Simplify this into 1 minus 6i plus 9i squared, where the last term becomes negative 9. So the whole square is negative 8 minus 6i. The next step is to multiply the remaining complex number to the simplified square. Distribute terms of the first complex number. Then distribute the factors to get negative 8 minus 6i plus 24i plus 18i squared, which is also converted into negative 18. So the final complex number is z as negative 26 plus 18i. The other exercise has monomials multiplied by complete complex numbers. Distribute the external factors to have I plus 7i squared minus 12i minus 6i squared. I squared are then transformed into negative 1. So we get I minus 7 minus 12i plus 6, which can be simplified as negative 1 minus 11i. The last exercise combines multiplication of complex numbers. So just the same, we distribute the first complex number and then multiply the external factors to take out the parentheses, thus having 2 minus I plus 6I minus 3I squared plus 2I plus 4I squared. Collect similar terms to have 2 plus 7I plus I squared, which we can transform into negative 1. Again, collect similar terms to get z as 1 plus 7i.